Hi everyone, so today we're going to be doing section notes on section 3.1, which is all about functions and relations. So this is the start of unit 3. So it'll be the very first lesson that we cover. So it's a lot of front loading just to write down. So go ahead and pause this video, write all of this down, and then I'll go through it. All right, so first things first, the definition of a relation. A relation is a pairing of input and output values. So domain and range, I'm sure many of you have heard those terms before. Domain is all of your input values, which are the X values. Range is all of the output values, which is your Y values. First thing we're going to look at is representing relations and what relations are and different ways to look at them. So one way that we can see relations is written as an ordered pair, x comma y. So for example, we're going to look at this set of coordinate points viewed in 4 different ways. So the first way is the ordered pairs. They can also be viewed as a table. So in an x comma y table, -2 comma 2, that's just written out like this in a table. So it's writing out the exact same information in a different way. We can also view it as a graph. An xy coordinate point that is plotted on my graph. This one is 3 comma 0, 0 comma 1, etc. So it's just another way of viewing the same information. And then the last way to look at it is called a mapping diagram. So we have a circle, or an oval, I'm sorry, I should say, an oval over here for the input, and then an oval over here for the output. So I want to point out my input values. I only wrote down 3 numbers, but I have 4 input values that are written down over here. The reason is because -2 is used twice. So when I do the mapping diagram, I only have to write it 1 time. But then my output values, all of them are different, so I write all 4. So for my mapping diagram, the first point, -2 goes to 2, -2 goes to 2, -2 also goes to -2. So -2 also maps over here to -2. And so on. So 0, the output is 1. So on my mapping diagram, 0 goes over here to 1. And then the last one, 3 goes to 0. So 3 comes up here to 0. I also want to point out that these are written out in order from smallest to greatest. So the smallest goes at the top, biggest number goes at the bottom for my input values and my output values. That just helps keep it organized, and it'll help you keep better track of your values. All right, so now that we've talked about what relations are, functions build off of that. So a function is when each input has exactly 1 output, and the key there is exactly 1. So let me underline that. Exactly 1 output. So think of this as like every function will be a relation, but not every relation will be considered a function. So it's like you have relations here for this big thing, and then functions stem off of that. So some of these relations will also be considered functions. It's like a smaller subset of them. So an example that I like to think about with this, determining if it's a function, think about it as your input is people and your output is birthdays. And I'm going to use this reference as we go through these different examples. We're going to look at input as people and output as birthdays. It's just a really good way of kind of bringing it into common terms, I guess I would say, to think about these problems and answer the question. All right, so let's go ahead and move this down. This is our first example. So I'll give you a second to write this down before we get started. Also a side note, so I know I showed you these in my presentation, but I'm super proud of how well my nails came out. I spent way too long doing them, but I'm really excited about them. I don't know if you can see this one very well, but my spiders, the little spiders, is kind of hard to see. But I'm super proud of them. We'll see how long they last. Anyways, so go ahead and pause this and write it down. All right, so our first example, is it a function? And we want to state the domain and range. So remember, x values, y values. So I'm given a mapping diagram here. So let's use our little analogy here. The input, that's my people. And then my output, this is my birthdays, or B-days for short. So let's ask ourselves, these are 4 different people. They each go to their own birthday. These 2 people here in the middle, are those 2 people allowed to have the same birthday? So ask yourself that. Are 2 people allowed to have the same birthday? Good. You should have answered yes. They absolutely are. There are millions of people born on every day of the year. So tons and tons and tons of people share the same birthday. So these 2 people are allowed to share the same birthday, which means this is a function. So I'm going to say yes, or yes, it's a function. You can either write function, you can write yes, it's a function, whatever you want to say. Now we also are asked to state the domain and range. So domain and range. All right, now domain is all my x values, so that's all of these numbers. So I'm going to use these fancy little squiggly brackets. Now remember, I think I've shown these before, if you're not very good at drawing that super nice fancy little squiggly bracket, you can just do like that, but just make sure you're doing it as some sort of little wiggly bracket. It is not parentheses or a square bracket like that. Those mean completely different things. It has to be a bracket like this. So either do a squiggly line or the fancy little bracket. This is also on your keyboard if you're not sure what it looks like. On your keyboard next to the P, that button that has this bracket and the little fancy squiggly bracket, it's the fancy squiggly one. Alrighty, so my domain, my x values are -3, -1, 2, and 4. Notice, since they were already written in order from smallest to biggest, it makes it real easy to write them in order from smallest to biggest. And then my range is 2, 3, and 4. Now, the reason why I don't write 2 through 4 is because it's not all of the values in between. If I said it was the numbers 2 through 4, that would include everything in between. It would include 2.5, 2.7, 3.4, 3.6, all the decimals in between, which are not the case. It is only 2, 3, and 4, the whole numbers. All right, let's move on to another example. Go ahead and pause the video to write this down. So now we want to give an example that is not a function. So let's just fill in random numbers. And again, I'm going to label this, these are my people, and these are my birthdays. So for the sake of using this analogy and making it make sense, instead of using negative numbers, I'm just going to do all positive numbers for the visual learners. So for my people, let's say we have a group of people standing in a line, and I'm going to look at the 10th person standing in line, the 12th person in line, the 17th person in line, and the 22nd person in line. And I'm just going to walk down that line, and I'm going to ask each person, when is your birthday? What day of the month does your birthday fall on? Let's say the answers I get are 2, so the 2nd, the 9th, the 14th, and the 31st. Let's say those were the answers that we got. All right. Also, side note, since I said I would show you guys my fun pens, this time I'm using a donut. Isn't that cute? I actually got this at a donut fest, which was this really cool thing. It was like an outdoor event like a year ago or so, where you got to go and there were like tons of different booths that were people like different donut shops, and you could go around and get a little sample from each one, and then you voted on which one was the best. You had to pay to get into the event, but it was really cool. You got all sorts of samples and got to try different things. It's a lot of fun. Anyways, back to the example. So let's say person number 10 in line, let's say they were kind of confused. Let's say they said 2 and 9. And person number 12 said 14. Person number 17 also said 14, so they have the same birthday. And then the 22nd person in line said 31. So when I look at this, the 12th and 17th person in line, they shared the same birthday. That's fine. Totally fine. Pretty cool that 2 people standing in the same line that close together have the same birthday, but 100% okay to share a birthday. However, this person up here, the 10th person in line, gave us 2 answers. Is it possible for someone to be born on 2 different days? Good. You all should have answered no. It is not biologically possible to be born on 2 different days. You're either born, even if you're like right at the borderline of a date, you are either born at 11:59 and 59 seconds, or you're born at midnight and 0 seconds, or midnight and 1 second. But it's still 2 separate days. And time zones don't count. You're still born on one day, whether you were born in Japan, or you were born in the United States, or you were born in Canada, or West Coast, East Coast, whatever. Different time zones, you still only have one birthday. So this would be a perfect example of something that is not a function, because the number 10 goes to 2 outputs. So I'm going to go ahead and write that out. This is not a function because, now remember, I abbreviate because as B/C. It's universally how it's abbreviated and how I will always abbreviate it in class. So because the input 10 goes to 2 different outputs. And you could have said that differently in your own words. You could have said 10 goes to 2 numbers, or 10 goes to the outputs 2 and 9. You have the freedom to use your own wording with that, just as long as you get the general idea that it has 2 different outputs. Now let's say, for example, we had the points 10, 2 and 10, 2. It just happened twice. That's fine. Maybe person number 10 in line, we just asked them twice and they answered the same thing twice. That's fine. That would still be counted a function. All right, now I want to look at this in a couple of different methods, because in your homework you will be given information in various ways and asked whether or not it's a function. So ordered pairs, if I were to write this out as ordered pairs, it would be 10, 2. And I want you to go ahead and pause this video, write down the rest of the ordered pairs, and write it as a table. So I'm just going to fill in the first one for you. For the ordered pairs, you're going to fill in the rest. So 1, 2, 3, 4, 5. Sorry, I just want to make sure I draw my table the right size. All right, so I filled in the first point for you for both of those, but go ahead and pause this, fill in the rest, and then push play when you're ready to check. All right, go ahead and check your answers. You should have gotten the same things. So it's just writing out this information from the mapping diagram as an ordered pair and as a table. I didn't show the graph just because I know that all of you know how to plot XY coordinate points on a graph. And our next example is also going to be looking at a graph. All right, let's look now at something called a vertical line test. So this is a pretty nifty tool. Vertical line test, also referred to as the VLT, This says, if it's possible to draw a vertical line, remember that's this direction. If it's possible, oops, I'll move that over. If it's possible to draw a vertical line that intersects 2 or more points at a time, it is not a function. Now remember, intersects means touches. So if it touches the graph at more than 1 point at a time, it is not a function. I'll underline that so you know that's the word I'm referring to. So we're going to look at an example now. Is this graph a function? And state the domain and range. So if I were to take a vertical line, I'm going to use a ruler. Make that look vertical. There we go. Hey, that looks pretty good. All right. So if I were to take a vertical line and move it across my graph, I want to know if it touches more than 1 point at a time. So when it's here, it only touches 1 point. But as soon as I start moving to the right, I'm touching 2 points at a time the entire way through this thing, which means it is not a function. Now I'm going to draw a little sample of that. If I were to have a vertical line, it touches more than 1 point at a time. So it's not a function. So you can say no, or you can say, actually I'm going to change that to a T and say not a function. So it is not a function. But I still want to state the domain and range. So my domain and range. Now, if you just call that D and R, that's fine. I'll refer to them as that later on. So my domain, again, this is all of my possible X values. So if I look at my X values, these arrows at the end of the graph mean that it's going to keep going on forever and ever and ever to the right. So my X values are infinitely positive. It'll go on forever. But when I go to the left side of the graph, my X values stop here. So at this point, which is -3, -3 is the smallest X value, and it's everything bigger than that. So X is greater than -3, but it can also be equal to -3. So greater than or equal to -3. Now my range, that's my Y values, the up and down. As this arrow up here continues going to the right, it's going to keep going up forever and ever, which means it's going to be positive numbers forever. This arrow down here, as it keeps going to the right, my graph is going to keep going down forever and ever. It has no limit, which means it can be everything. And the way we say everything is all real numbers. So you can either write out the full word, all real numbers. You can write all real numbers like this, or you can do this fancy, cool little symbol. Now this symbol is an R with a double line. So whether you draw it like that, so I draw mine where I do 2 lines, and then let me do this so you can see my pencil. So I do 2 lines, and then I make the capital R. So some people do that. Some people do it where they draw this stick going up, and then that, and then draw a second line. Some people do it where they do an R like this and leave a gap, and then draw a second line down. Whatever you prefer, as long as it's an R with a double line, then it's fine. Alrighty, that is the end of our notes. Have a good rest of your day.